Let's discuss cavitation. What is it? Cavitation is the occurrence in which vapor bubbles form quickly and abruptly collapse within a fluid, resulting in a distinctive noise in the machinery where this phenomenon takes place. It's a common phenomenon in ship propellers, pump impellers, and that's exactly what I want to discuss, namely cavitation in centrifugal pumps. Centrifugal pumps have characteristic operating curves according to which they must operate. The most classic is the flow rate and head prevalence curve, where one is a function of the other, as they are related based on the hydraulic characteristics of the flow, where we can see the behavior of the pumps. They then have the curve related to the absorption of the electric motor of the pump, that is, how much current, how much energy the pump absorbs depending on the operating point, therefore the pressure at which it is working, and a curve that is that of the NPSH, that is, the maximum suction height at which a pump can work. So let's talk about centrifugal pumps that typically have an NPSH, which means they are not self-priming pumps that can independently draw water, but they must first be primed or filled with water, and secondly have a water suction height that does not exceed that indicated by the famous NPSA curve. Because if we compel, so to speak, a pump to operate with a lower water suction value than the characteristic one, we will undoubtedly experience the detrimental phenomenon of cavitation. Cavitation is an extremely dangerous phenomenon because it can lead to damage to the impeller and the pump itself in very short times. We can also observe this phenomenon on ship propellers. If you examine these images, you can understand what is occurring. What takes place in essence? Bubbles of air are formed near the profiles of the blade of the ship's propeller. These air bubbles cause a decrease in the propeller's efficiency of the ship and a characteristic noise. The identical phenomenon takes place inside a pump impeller. What actually transpires? Typically, bubbles of vapor form in close proximity to the attack profiles of the pump impeller because we exceed the vapor pressure, leading to the evaporation of the liquid, or it descends to a pressure so low that it undergoes evaporation. Here we should refer to a principle of physics related to water. We know that water boils at 100 degrees, but if we put it in a vacuum container, the boiling temperature drops significantly. Well, when we create a pressure deficiency, therefore a very high depression in the impeller area, this causes a vaporization of the fluid, a vaporization of the water. The process of water evaporation causes micro-implosions that can damage the plant's impeller. In these images, you can see some examples of damage caused by cavitation. It is an extremely dangerous phenomenon, but the phenomenon of cavitation can be induced not only by an incorrect value of NPSA, but can also be induced by an incorrect installation of the pump, for example by suction collectors sized incorrectly, therefore with diameters not sufficiently suitable for the pump's design data. Or from collectors that have roughness, that have sharp edges. For example, if we put a bend or a T very close to the pump on the suction, these edges can generate depressions that cause vapor formation and therefore cavitation of the pump. This vapor is distributed on the impeller, accentuating the depression in the suction area of the pump, destroying the impeller. So it is important when installing a pump to pay close attention to the NPSA values, to respect the suction height of the pump, or to place the pump below the water level, thus creating a positive pressure on the pump's suction. Similarly, it is important to properly design the suction manifolds and to be very careful when sizing the bottom valves, check valves, and suction valves. All these factors must be carefully controlled, otherwise the damages are irreparable. I hope I have been clear. If you have any other doubts, feel free to contact us. Thank you and have a good evening, everyone.